This video is about translating figures. So if you're on a coordinate plane and you want to translate a figure right or left or rotate it or reflect it, that's what we're talking about in this video. So as I give examples, I'm going to give examples of just one point, but obviously if you're moving a triangle, you're going to need to move all 3 points of the triangle, or a square, you'll need to move all 4 points of the square. So while I just show you one point, make sure that when you're actually translating these figures that you do that to all of the points. So to start, translating left and right and up and down. So left and right, whatever it's asking you to do, I'm going to call it the translation number. So say it says to translate it up to, then your translation number is 2. Say that it asks you to move it left 5, then your translation number is a -5. So whatever that translation number is, you're just going to add it to all the x values, and then your y values are going to stay the same. Those don't change. And then once you've changed all your points, if you replot it, then you will have your new translated figure. So an example of that with a specific point is, say I have the point 3, 2, and then my translation number is 3. I want to move it right 3. Then I'm going to add this 3 to the x value. So I have 3 plus 3 is 6, and my y value stays the same. And then up and down is pretty much the exact opposite of moving left and right. So we're still going to add that translation number. But instead of adding it to the x values, we're going to add it to the y values. And then our x values will stay the same. So another example of that, say again I have my 3, 2 point. This time I want to move it up 3 instead of down 3. So instead of adding that 3 to the x value, my x value stays the same, and I add that 3 to my y value. So I have the point 3, 5. Now, when you're given a figure on a coordinate plane, sometimes, in fact, I would probably say most of the time, it's easier to just move it. Like if it says move it right 3, well then you're just going to take your point, count over 3, draw your new point. But using these rules is sometimes nice if you're dealing with really big numbers, like 171. You're not going to want to count out 171 squares. It would be a lot easier to just add 171 to your x value. So they do have their place, but if you're dealing with really simple numbers and it's easier to just count it, then it's totally cool to just count it. Then our next couple are reflecting. So I'll switch colors. So reflecting over the x-axis and reflecting over the y-axis. So starting with reflecting over the x-axis, in this case, our x values will stay the same. So whatever your x value is, doesn't change, stays the same. The y values aren't going to change, like we're not going to add or subtract anything to them. Their sign is just going to change. So y values, signs change. So if it's positive, it's now going to be negative. If it's negative, it's now going to be positive. So an example of this, we'll still look at our 3, 2 point. If we flip it over the x-axis, our new point, our x value stays the same, so it will be 3. The y value, the sign changes, so I have a -2. So 3, 2 to 3, -2. Reflecting over the x-axis, reflecting over the y-axis is just the same but backwards. So instead of the x value staying the same, the y values stay the same. And the signs change on the x values. So an example of this is, instead of, like above, how our y value, our 2 became a -2, this time our x value, 3, will become a -3, but our y value of 2 will stay the same. So that's how you can go about reflecting over x-axis and y-axis. And then our last section is about rotating. And this is a little bit difficult to teach because obviously there's going to be different rules if you rotate clockwise versus rotating counterclockwise. And in classes, I've actually taught some classes one thing and some classes another thing because I've been trying to figure out what's the best. I think probably the best way to teach it is to teach clockwise. So this video is going to teach the clockwise version, but if it's a little bit different than what you've seen before, you probably learned counterclockwise, which is totally fine. But for the purpose of this video, we're going to do it clockwise. So when rotating 90 degrees clockwise, our x and y values switch. And then the sign changes on the new y value. So I think this one is really helpful to see an example. So again, we have that 3, 2 point, and if we rotate at 90 degrees, our 3 and 2 are going to switch places, so now we have 2 and 3, and then the sign changes on the new y value. So this 3 is my new y value, so this is now going to be a negative 3. And then when rotating 180 degrees, I think this is one of the easiest ones because you don't have to switch anything. All that happens is the sign changes on the x and the y values. And a cool thing to note about this is it doesn't matter if it's clockwise or counterclockwise. No matter which way you go, your sign's just going to change on your x and y values. So clockwise, counterclockwise, it doesn't matter. You do it the same way. So again, that example, I have 3, 2, and if I rotate it 180 degrees, it's now going to be negative 3, negative 2. And then rotating 270 degrees is very similar to rotating 90 degrees. So our x and y values switch. And then our sign changes on the new x value instead of on the new y value. Oops, on new x value. We'll go ahead and fix that. So again, with my standard example, I have 3, 2, and then my x and y values switch, so now I have 2, 3, but this time the sign changes on the x value instead of the y value. So like I mentioned, rotating 180 degrees counterclockwise and clockwise doesn't matter. Now for rotating 90 and 270, what I've written down is the clockwise version. But let's say it asks you to rotate it counterclockwise, then these rules just switch. That's all that happens. So if you're rotating counterclockwise, so if it's counterclockwise, then this is the rule for 90 degrees. And if you're rotating counterclockwise, then this is the rule for 270 degrees. So you can really you know the rules for all of it, clockwise and counterclockwise. You just gotta kind of keep track of which one's which. So what I have written here is clockwise, but if you just switch your 270 and 90 rules, then all of a sudden you're rotating counterclockwise.